Teen Titans have defeated the Hive, so let's get going on 6-5. This is Mr. Meyer from Way Happy Studios, and we are going to talk about the graphs of polar equations. And they are fun, just like when you learned to graph originally with X and Y, and you plotted a bunch of points, you made up X's. Well, this will be a little different. You would make like an R theta graph, and what would happen is you would pick some angles, like usually 0, 15, 30, blah, 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 as much as you would like, all the way down, maybe even to 360. And you would plug those into each of your equations and find out what your R values are so you could plot those points and get some of the most beautiful graphs. And so some of the graphs you will see are called roses or Lima zones or lemniscates. And it's just, there's awesome looking graphs, and you can see 3 of them right there on your screen. So we got to talk about them. So again, you know we love to analyze polar graphs, and one of the first things we talk about in analyzing polar graphs is symmetry. And so let's talk about symmetry. You can look at this first graph, and you can see that this graph, 6 cosine theta, this is what it looks like. And you can see it definitely has x-axis symmetry. You can look at the second graph and see this one, 4 plus 4 sine theta, definitely has y-axis symmetry. And you could look at this last graph, 4 cosine 2 theta, and you can see that it definitely has origin symmetry along with x and y. And so therefore, when you look at all these graphs, the fun part is how can you tell, without graphing it? What if you just wanted to mathematically check? And you remember, just like before, when you do it with x and y functions, you could plug in negative x, and if it comes out to be the exact same function, it's even, and if it comes out to be the opposite, it's odd. And same kind of things here, except for you get to check 2 different things and just try to get one to work. So if you want to check to see if it has x-axis symmetry, you could plug this in other words, keep the r alone but change the angle. Or you could change the r and do pi minus the angle. Either one. And if it comes out to look as the original, then you have x-axis symmetry. So let's try it. I copied the equation. Oops, I didn't copy the equation completely. I meant to have 6 cosine theta. So it would be the exact same graph as up above, which we know has x-axis symmetry. And let's just go ahead and prove that. So the way I prove it is I'll try the first one. Remember, you could try both. Once you get it to work, you're good. So I'm going to copy the r, and I'm going to put in a negative theta, and then I'm just going to see what I get. Now we just have to think back. Is cosine an odd or even function? If you've forgotten, kind of draw it and be like, I know cosine goes like this, so look at that. It's definitely an even function. It's reflection over the y-axis. So if it's an even function, that means this negative doesn't matter. So this is the same thing as 6 cosine of just plain old theta. And now you compare it to the original, and you say, whoa, right off the bat, they're good. Therefore, I know this has x-axis symmetry. And so we're feeling pretty good about that. All right, let's take the second one that we have there. This one that is supposed to have y-axis symmetry. And again, I will first plug that in. That's my code for y-axis symmetry. And I will see that it has this y-axis symmetry. So I'm going to change the r, and I'm going to have 4 plus 4 cosine of the opposite of theta. Now remember, we just talked about cosine, and good old cosine is an even function, so you no longer need to have that negative out there in front. Oh, man, I really failed on my copying, didn't I? This was supposed to be sine theta, and so this therefore should be sine theta. And sine is an odd function, so the negative could come out front, so you'd have negative r equals 4 minus 4 sine theta. And then what I could do is just divide by negative to get the r positive, and we'd have negative 4 plus 4 sine theta, and then we compare it to what was supposed to be the original, and lo and behold, oh, this guy doesn't work. So it does not have y-axis symmetry yet. But then you go in and you plug this guy in, and you hope something better happens, and it better show us y-axis symmetry or I'm in big trouble. And so first thing I'm going to do is I'm going to leave the r alone, and then I'm going to put in 4 plus 4 sine, and then I'm going to take out the theta and put in pi minus theta. And so now I'm feeling pretty good. I just got to show that that's the same as the original. Well, look what you got here. You got sum and difference formulas. Remember, those were the songs. Remember sine, cosine, cosine, sine, cosine, cosine, sine, sine, those things. And so now we got to do that. So we got to say, all right, this is 4 plus 4. Now use that song. This is sine. So it's sine pi cosine theta, and same sign, minus cosine pi sine theta. And all that's multiplied by a 4. And so now I can go ahead and figure out what that is. Well, let's see. Sine of pi, I'm going to fold down my pinky because the reference angle is, that's pi, the reference angle is 0. And so that's the same as 0 degrees. So sine of pi is 0. So this is just 0. So that means all that's gone. Cosine of pi, well, that would be 1. But since it's pi, it's over there on the left side, it's actually negative 1. So what do I have? I have r equals 4 plus 4. And then here you just have two negatives, make it a positive sign. And notice back at the original problem, if I would have written it right, I would have had 4 plus 4 sine theta, and therefore we do actually have y-axis symmetry. And that's how you go about proving symmetry, right? You could do the same thing with origin symmetry. So plug it in and show that it works, and life is good. All right, another thing we like to do, analyzing graphs, right? So when you look at these crazy polar graphs, there are going to be some things we want to analyze about them. It's not as hard as functions, right? It's not as many things to do. First thing we might talk about is domain. Domain is what angles can you plug in? Well, that's usually all the angles that you can think of. You can plug in as many as you like. So go to town. The more you're willing to plot, the better. The range is the R values, and we'll talk about that in a minute. But how do you find those R values, right? When you plug it in at all these different angles, we have to talk about what's going on, what's happening to the R's. Boundedness varies on the different graphs. A lot of them are bounded, but some are not, above and below. Continuity, they are usually very continuous. You can draw them from one point to the other. And symmetry, we just talked about that. So let's talk about the range, or the maximum for the R values, right? So there's two ways to find it, and I usually take the quick way. If an equation has the word cosine or sine in it, I know that the most that cosine can be is 1, and the smallest cosine can be is -1. Same thing for sine. So I usually just plug those in and see where my R values are going. So look, if the biggest thing I can get out of cosine is a 1, then this equation would be R equals 3 plus 2 times 1. The biggest it's going to get is 5. If my cosine, the smallest it could get is -1, that means this equation would be 3 plus 2 times a -1. That means the smallest this equation possibly could get is 1. Therefore, my range is between 1 and 5. So all of our range values, all our R values will be between 1 and 5, and that's our range. So in this problem, our domain would be any angle you want to plug in. So anything, all reals, but our range would only be from 1 to 5. Let's let you try a problem, and then we'll come back and talk about roses. All right, good work again as we talk now about the two types, or actually more types, of most common curves that you will see in polar coordinates. So one of the most popular is rose curves because they're just darn pretty. You can see a bunch of them right there next to them. But most important, you want to realize that you can recognize them from their equations. So if you just have R equals cosine or R equals sine, you're going to get a beautiful rose graph. N actually tells you the number n in there, tells you how many petals you have on your rose. If it's an even number, then you double that n value, and that's how many petals you will have. If it's an odd number n, then that's exactly how many petals you have. A, the number out front of the word sine, like the amplitude back when we graphed it, that is actually how long each petal will be. So that will always help you with your range kind of values. And if it's cosine, it has x-axis symmetry. If it is sine, it has y-axis symmetry. And sometimes it can sneak in and have origin symmetry, but not all of them. So we can't say that, but it can say it with a certain amount of petals. And those are really pretty, and I encourage you to graph them. If you grab your graphing calculator and type them in, they're fun. Make sure you change your calculator's mode to polar. You probably want to be in radians mode, but you have to adjust your window to make sure that it all makes sense. So play around with that. Another one that's really fun are the Lima zones. They are the ones that are down here. They have actually 3 different types: looped, dimpled, and convex. Just depends on what the multiplier is, the numbers out front, I'm sorry. And so if you see, there's one form here of Lima zone, which is if you have a number plus a number, sine the angle, or a number plus a number, cosine the angle. That will build your different Lima zone curves. The range right there, you can just see, you subtract those 2 numbers and then add those 2 numbers. Cosine has x-axis symmetry, y is, and again, I would really encourage you to either graph them by hand, which takes a little bit, so it's really more fun to graph on a calculator. So if you grab your calculator and look at these beautiful graphs and test out the theories there, you know, by making A bigger than B or whatever, you'll get to see some cool things. And then there's a bunch of other curves too that you can see. Probably the most popular ones, again, will be your rows in your Lima zone, but don't leave out lemniscate, which has an r squared, which usually makes it pretty easy to identify. The cardioids, which have the exact same number twice. And then everyone's favorite is probably the spiral of Archimedes, which doesn't have a sine or cosine in it, so it's really easy to see. However, it spirals really quickly, so your window's going to go crazy. In fact, and it's also kind of a fun one to talk about, because the spiral of Archimedes, if you graph it from 0 to 2 pi, it's going to shoot off and it's going to just go like this, right? But if you go negative 2 pi to 2 pi, it will graph that one, but it will also graph this one, which is a nice reflection of it over the y-axis. So it does actually have some y-axis symmetry, which blows people away, and actually blew me away the first time I thought about it. So these are all fun little graphs. You can type them into your graphing calculator, make your own, and we will mess around with them in class. And I will see you later. Have a great day and stay happy.